We're back, and we're on slide number 59 of the Perl lecture. And let me quickly get to the slide number 59. Wow, that was a long lecture, wasn't it? Oh, no, I went too far. Hold on. Oh, jeez. That was not too productive. Hold on one second. Well, as I'm going through this, I can kind of tell you if you missed this first part and you're just showing up now, you want to go back and look at the video, minus the interruptions that was going on. But it did go over most of the features of the language, and we almost made it through until the room got too small for everybody, including me. And I ended up on slide number 59 talking about splitting. We went into some of the built-in functions, and these are built-in functions, by the way, so it's not a bad thing to mention that. Split, as an example, join, subroutines, which are nothing more than another name for functions in Perl. And the concept of private variables used inside of these subroutines or functions, the semi-private or local variables. And then the concept I ended on was the concept of requiring variable declarations. So programmers that can choose to require declarations. So you can use strict or use strict vars, which says you can't use a variable unless you've declared it, or unless you've initialized it, which is really much the same thing in Perl. There's a declaration and an initialization that we have in most languages where we define a variable. Usually when we consider definitions of variables, it's about associating a variable data type with a name that represents the memory that's being allocated for that particular variable. So we can get at that memory address via the name. And the memory address is holding a particular data type. So that's the traditional sense. It's a little bit non-traditional, essentially, in Perl in that we don't have to declare, we don't have to initialize variables before we start using them, except if we want to enforce that rule, and then we use a use strict. So the compiler will be strict in requiring that variables must be declared private with my, and otherwise the variable must be declared with package names. And looked at my right here. Using my in this particular sense makes a private variable, and it actually does two things. It makes it private, but it also declares it as a variable inside of, and it's a private variable in this particular case, inside of the sub function in this particular example. And we're using the same, the variable here in this example was sum, and sum was made private by using my. So in terms of the declaration here, and I don't really have an example for it, but it will essentially, if you use strict, then the variable must be defined, must be declared private with my. You must use my with that. Most programs aren't going to do that unless they want to make sure that some integrity is maintained and that the script is reliable. It creates more reliability in the script, if you think about it. It requires certain things to happen. Functions can also have arguments, just like function parameters or arguments. Passing arrays. We are familiar with passing arrays in C or C++. In this particular example, passing references to arrays or passing arrays. We can also pass hashes. So if we say this is a scalar, here scores is equal to the average, and this is a function call, average, and here are parameters, math, English, and French, and let's say these were grades, and you're going to come up with your average grade for your score. We could pass the references to arrays, we could pass the hashes, and here, get rid of this minus sign again, it's a bullet point. Checks is equal to payroll. And then we're using a hash in here. This is the percent symbol tells us it's a hash, so passing a hash. Passing references to hashes as well is also possible. So we also have signal handling in Perl, and this might look familiar for anyone who's seen signal handling in Unix, who's ever done any thread processing. And that's actually we're going to talk about threads and signals in the next lecture. So I'll hold that definition for a few more minutes, but. We can catch signals, handle signals, and work with them in Perl. So the special hash here is the signal, because we have a signal name and then we have a code or something that went along with it, or a description. So used for signal handling, the hash keys are the signal names, and so we have sigchild, hup, all these are signal. And these are just the traditional Unix signal names, and then the hash values are the signal decisions. So ignore default, use the default action. So ignore signals here, sig int, ignore, resetting it, put it on the default, catching it, go to my catch. And when you go to my catch, it's going to like run something, or it's going to save it, catch the signal, and you can process it and catch it with some function that you might do for signal handling. And as I mentioned before, we also have, and I don't know if I mentioned this at all yet, but everything in Unix is considered a file. So if you have a directory, it's really a file. If you have a file, it's a file, obviously. If you have a device, it's really a file. So I/O are files, actually, as well. Everything is considered a file, which is kind of weird. So file handlers are used, and recommended use of all uppercase letters with all file handlers. So the three handlers we have is standard in, standard out, standard error. And this actually is recommended but not required. You can actually use a file handler. You can define file handler for standard in with all lowercase if you wanted to, but it doesn't match kind of the Unix standard. File handlers in Unix. In fact, devices in Unix are usually in uppercase as well. Device numbers and things associated with it. It's just a way of quickly looking at something and knowing what you're looking at. It's kind of a self-identifiable name if it's in upper caps or if it's in lowercase. In terms of file handling, we can open a file for reading, and here we have a file handler that's in here with a file name, and then we're running an open. And that might actually look familiar to you as well. It's a system call. So in a first weekend lecture for this course, I talked about system calls and how they were built in, or ways of communicating with the kernel. From the user mode, you can run a system call. It goes down and asks the kernel to do something. The kernel goes ahead and runs something, opens a file in this particular case, processes it, and then returns back to the calling process that called it. And this is a classic example of how Perl is actually kind of popular. You can write system calls in Perl. It supports the system call interface. And there's no API on top of it, which is interesting. Sort of like C. You can use the lower level system calls in a C shell script, and I'll talk about that later on today, or in C programming without having to use the higher level APIs for things like I/O and stuff. And when I say that, let's say, for example, to compare it, if you talk about opening or reading, actually, open is pretty much the same. The system call and the API call, there's not very much of a significance. The only thing different is with the C++ or the C API for open, you've got a file descriptor, which is a pointer. When you open up the file, as an example, it loads it up into a buffer, and you've got a pointer, that memory buffer, that's automated. The open system call itself is just handling the low-level read, opening up the file and getting the information from the file. And here we have die, which is the equivalent to open that file, or die, that we're going to put in here. So die meaning sorry, could not create the file name if the file handler was larger than the file name, which means it didn't open actually. And die is actually kind of an interesting thing. It's just, it's an automated way of doing error checking. Normally you do a try and a catch or something. So die is actually kind of equivalent to a catch, sort of. Catch and an exit, really. Because die basically closes down everything. Stop. It's a stop command. So write into a file, noting that no commas after the file handler, which is interesting. So here we have a comma after the file handler with the file name and that syntax. So we have a little inconsistency in terms of the system call. But here we're doing a print file handler, hello world. So Perl provides the .op optional file test, which is like just like in the shells. So you can test to see if the file actually opened before you printed it, so before you wrote to it, before you read from it, stuff like that. And we'll take a look at some of those parameters in the next lecture. In terms of executing Unix commands, as I mentioned before, we can put Unix commands inside of Perl scripts. So you can capture command output, use a command substitution, capturing the output in a scalar. The who system command, you go to a terminal prompt, type in who, it's going to be who are you? It's going to give you your username. So here you can take the username and copy it to a variable. We can capture the output to an array. So we can have who, and it comes back into an array in this from the @ symbol, we know this is an array versus this one is just a scalar. And so to execute a command without capturing the output, we use system. Actually, system, a lot of C programmers use. It's just a way of running actually, you can use system in a Windows environment. You can use system in a Unix environment. It just runs a program. System Notepad opens up Notepad for you. So it's kind of system is an automated way, believe it or not, of creating a process, forking off a process and running a program and then ending it. So somebody's talking in the back. Is that outside or inside this room? Maybe we can shut that door. I'm hearing some like background talking. Anyway, we have so many interruptions today. It's just distracting, I'm sorry. Reading directory files. So we have this reference out there again. Remember earlier in the slide set from the last lecture I mentioned an MIT reference. They're the ones that have done a lot of, hopefully that door didn't just lock. Can you check? Okay, good. They're the ones, MIT Research is the one who's basically done a lot of the improvements and modifications and continues to build on the language, and they have the best documentation out there. There's another one called a cookbook. So if you go on, just open up a Google browser and type in Perl cookbook. This is where you see a bunch of things that are kind of nice. They're add-on modules and pieces. So one of the best features of Perl in general is that of the third-party modules. So third-party modules are sort of like APIs in the API world. We load on an API to give us more functionality. And most people are familiar with Java. You call them packages, essentially, or full of API, classes that can be added in. So one of the most popular ones is opening directory files. And so you can use an open dir to set up a directory handle, and you're basically automating, instead of just doing a low-level open and then create a buffer and then add the stuff to the buffer and then create a pointer to the buffer and all that other stuff. You run, and this is what's open in the C++ world. That would be like an API written wrapper on top of a system call. So in the Perl world, it's a module written on top of system calls, and you load on the module and you run all the module functions, all the commands. So here we have open dir. We have use read dir in scalar context to read the next entry. So while it's defined, the file name is going to equal to, well, read the directory. And we have a directory handler. And then the directory handler is the open directory that we created. And it's a lot more automated, just as you might have noticed with the differences between running system calls and system call interface and running higher level APIs. You probably don't understand what I'm saying unless you've done any Unix programming, systems programming, where they required you to run system calls. If not, what you've done is higher level API programming. And the difference really between systems programming and application programming is the level of the APIs you're using. So no API, you're really doing system calls and you're doing systems programming. APIs, the bigger the APIs, the more functional, the higher the generation of the language. And as an example, assembly language, no APIs. No system calls really either. You go up a level and take it to low-level C from a Unix environment, not too many APIs, but you can add them on, but mostly system calls and systems programming. You're writing device drivers at that level. Or because you can't load on an API to write a device driver in most cases in a C environment. You're creating DLL files, you're creating device drivers, you're creating all sorts of low-level, system call interface, which runs faster, runs more efficiently. It doesn't require as much support from other files. It gets a smaller footprint, smaller executable. It's kind of like, the difference between assembly language and Visual Basic. Compare the size of those two executables. Assembly language is going to be really small and efficient. Visual Basic is going to take up half your hard drive. So it's going to be really huge difference between those two. But in the Unix world, the higher level the APIs, the higher level the generation of the language normally, which is where most programming languages actually came from. The root of all languages is from B, and from lower levels of the implementation it came from Unix, essentially. So as a computer science student, and especially as a programmer, it's nice to be familiar with Unix because that's where everything came from, essentially. But anyway, as I was saying, the higher level the API, the more functionality you get for free. the less implementation, the less code writing you have to do, the more automated your code statements actually are, fewer lines of code you write. So, but there's a compromise for that. Anyway, so using database manipulation, most Unix systems have a standard library called a DBM, Database Management System, and which allows programmers to store a collection of key value pairs into a pair of disk files. So in Perl, a hash may be associated with a database management system through a process similar to opening up a file. So we have DBM open function that associates a database management system database with a database management array. So inside of Perl, we have the ability to actually create a pseudo database using a hash as the underlying implementation. And it's a module that you're loading on, actually, Perl database module. And that module is giving you database functionality. Is it going to be like Oracle? Close. Is it going to support all SQL? Maybe, but maybe not. Is it usually just used for data storage? So it's like creating, in the old days, you guys remember like DBF, database file system? Some of the, pre-Oracle, pre-client server, pre-Microsoft Access. It's more on the levels of a DBF compatibility, which was a file that was really a hash. Actually it was an extended hash because we had keys, which were what? Primary keys. And then we had values. But, a database just has more than one value. A database, one value with a key is a hash. A database is one key with multiple values, which, what are they? The rows, if you think about it. And there's no order to it. It's by key. So if everybody was in by a primary key of a student ID, for example, in this class, we could look at the attendance list and check out all your names, and all the associated data, your email address, everything is associated with your ID, which is essentially what you're doing from a programming perspective in Perl. So you would open up a database, and if you had this module loaded, and I believe actually in modern day Perl implementations and builds, it's actually in there automatically. Which is the other interesting thing. In the earlier versions of Perl, if you want to compare the different Perl versions, there was less in it, and it was real small. And Perl would fit on like really small systems. But systems get bigger, hard drives get bigger, memory gets bigger. Oh, just include more stuff in the standard, especially if everyone's adding it anyway, just put it in there. So the builds in Perl have gotten really big over the years. And now it takes almost like 20 minutes to install it, If you're doing an apt-get on it, or if you're installing it from a disk or something like that. It'll take you a lot longer today, only because it includes a lot more. But you don't have to go out and look for all this stuff and add it on manually. So here we have a database open, Fred.mydatabase, delete Fred, Barney, and then we're looking at hash concepts. And we're looking at, and this is we go back, and from before lunch, we're going to take a look at some of the hash operations, and lo and behold, it's the same. So the hash operations are used on databases, and so it's a lot of commonality between the two. So you open up a database, you open up another database, you delete an item. While this key equals this value for each one of the Freds, print out the key, or the value, has the value of, and then the value. So essentially what you're doing is creating a very programming-related data structure / database that works with Perl programming. And the difference between this is you're not going out connecting to a database, logging in, opening up a table, writing into a table. Instead, this is a data component that's stored with Oracle that acts like a database. It is a database. Think about it by definition. A database is nothing more than a key that has multiple values that are associated with it. And a hash is sort of a database, but most people would consider a hash more of a dictionary versus a database, because databases usually store multiple values. But anyway, Perl debugging, we can turn on the -D switch, and it'll show debugging messages. Why do we want to, by default it's really turned off. Because if you wrote this nice, beautiful script and it was running on a client computer, do you really want to see, this random error that you put in there that comes back and says, hey, stupid, you forgot to take this out. If you and it causes a problem, and there's this debugging message. So it's kind of like the differences between the different. In fact, they still use this terminology. Any compiler you get will always have a release version and a debug version, you know, and it's just a level of messages that are involved in terms of the compilation. I mean, are we going to really put the status updates and the messages and the error codes and everything in there? In the release version, we strip it all out because the customer doesn't even need to know that, because it should work 100%, right? It should be perfectly fine, and it's not going to generate any of those errors, so why do we need them in there? So we take them out. Makes it more of a finished product sort of thing, you know, the release version. So H prints out the help messages, T will do the stack trace, S will be the single step. That's misspelled, actually, single. So some little edits I need to make in here. N for finish, N for next, F for finish, C for continue, Q for quit, D for delete all the breakpoints. So that's the debugging features of the language. So I already mentioned the concept of system calls. So this is kind of a review, but Perl provides the interface to many of the Unix system calls, which is why it's a very popular Unix scripting language. The interface is via the Perl functions, not directly through the system call library. We actually have an API. We actually have a Perl API that's created. That's actually not really in the form of an API. It's through the implementation of Perl. And it goes through the functions that calls the system calls. Why does it do that? Because it can combine multiple system calls into the same function, and it can automate. So it does provide a little bit of automation versus just the regular old system call interface, and it's only for common stuff. Some of the, you know, some of the system calls is a direct translation from the system call to the function library. So the interface uses a dependent on the implementation, the version of Perl that's being used as well. So you can actually call the system calls, as we've seen earlier, or you could use the Perl version of the system calls, and that's going to be related to the version of Perl that you're using. There's multiple versions of Perl out there, actually. Perl Modules. This is the biggest selling point for Perl. So Perl Modules may extend symbols to your namespace. You may use a use to import these symbols. So it's kind of like, you know, when you include something in C++ or C, you import something in Java, now you use something in Perl. It's the same concept. You must use the use to import these symbols. An example of that's what you're going to find out with the CGI interface if you take that step with that first program that I went over earlier today. If you use CGI, well, it loads on a CGI module. So it may request only certain symbols be imported. So use CGI and then bring in these symbols. So it's used to create, you know, may export symbols to your namespace. You can make your own modules. So steps to make a module. Module name should not be all lowercase. You know, it should be uppercase to begin with. It's kind of like, actually, the module best practices or syntax or whatever is very similar to classes these days. And classes are sort of like modules. If you think about our objects, are sort of like modules. You always capitalize the first letter of the class module. Module files and package names should match. So if it's module ABC, the package name should be module abc.pm as package. And then PM is the short abbreviation for the package which you're using. And the package statement is package, which is the same as Java, actually. So from a programming language concepts perspective, you can sort of see how these languages are very similar. How Perl is kind of like the foundation for a lot of other concepts and a lot of other languages. Most of the modules should load in the standard exporter module and then create 3 different special arrays. In this particular example, use exporter. And now we're going to do an ISA, name of the base classes. Export, the default symbol for the export here. Export OK, symbol for the on request. So don't really be concerned about it. In terms of the final, the basic fundamentals of Perl, what makes it unique as a language. I'm not going to ask you any questions about any particular modules or anything. And the other thing too is you can find a Perl module for practically everything. There's Perl modules that do MP3 encoding. There's Perl modules that do video encoding. In fact, that's really popular right now, actually. You load on a Perl module and you can take at a command line interface and very efficiently read through, because what is Perl? You know, it's for extraction. It's extraction and reporting language, right? You read in a, let's say, MOV file as an example. and you can parse out through a Perl script. In fact, there's Perl scripts out there actually that are doing this that you can download and install. You can take an MOV file and turn it into an MP4 file, or an AVI file and turn it into an MOV file or something, but it's just a translation in a lot of cases. So you read in the audio, you read in the video, two separate tracks, and Perl keeps track of them in two separate string arrays or something, or character arrays. Applies a module to it that's built in that says translate or something, and it takes this whole bunch of characters and translates it to that whole bunch of characters over there and writes it out to a file. And voila, you've got video translation. In fact, a lot of it's being done that way because it works in Unix, works on multiple platforms. And when are you going to convert a file? It's going to run as a script within a program. So like, for example, you have this file and it's on a disk. It's a .vob file, and you want to read it in, and you want to translate it and strip out the DRM or something. Or hopefully it's not a DRM. Hopefully you're not pirating a file. And you want to, a lot of Perl utilities are working behind the GUI interface that's doing this, that's going out and providing all of the processing. So Perl's a general processing language. So next comes any module initialization code that might actually happen, some function definitions in terms of steps of making a module, compiling your own module, that is. Files needed to return some true values to indicate success. So we can kind of start with loading the standard exporter module, creating different arrays, loading on initialization code, and essentially building your own module. So the modules themselves are pretty easy to build, which is why there's a lot of them out there. Most of you will probably just end up, figuring, oh, we need to download a module. And what ends up happening is what you find out is like you're working with an environment, you install a program, and then it comes back and says, it requires Perl. And you're like, oh, I don't have Perl on here. So you'll just click the button and it'll install Perl for you. And if you actually go out and look at it, you'll see a bunch of PL files. Most of the files have a PL extension on them. And it'll run Perl for you, essentially. So, all right, well, that's the end of the Perl lecture. And I probably could have gotten through it before lunch, but I didn't really. I was giving up at that point. So, questions, comments, concerns about Perl before we move on to bigger and better things. And just so you know that this is labeled Lecture 8 if you're downloading them from bhacker.com. So I'm going to stop this video because I'm going to start a brand new one on a different topic completely. Just a way of organizing